All right, y'all. We're looking right now at the second section of our Topic 12 notes. And we've got a very short section of notes today, just one theorem and then one example right here, all on the same slide. Okay, so let's look at that theorem. We're talking about tangent segments. Okay, so first of all, we need to remember what that word tangent means. Okay, tangent. If you're describing a line or a line segment or a ray that's tangent to a circle, that means it runs right up next to it and it touches the circle at one single point. And that's how you keep track and remember that, is that a tangent touches the circle. Okay? So if that is the case, and you've got two tangent segments that are drawn from the same external point, go ahead and underline that. It's what you fill in on your notes. Two tangent segments drawn from the same external point, then they are equal. Now, I'm not a big fan of that phrasing that it gave us on these notes, so I'm going to fill in a different word, a more math-centric word that we've usually used, and that word is congruent. Okay, that's the word that we usually use. Instead of saying that line segments are equal to each other, we'd say that the line segments are congruent, and that's how I'm going to be talking about them today. Okay, so when we look at this diagram right here, we can see that CD and CB are both line segments. They are both tangent to the circle. Okay, they run right up next to the circle and just touch it at that one single point, point D and point B. And since they both came from this same point out here, they're both tangent, they both started at point C, then they are congruent to each other. BC is congruent to DC. All right, so as we look now at our example problem, you may be asking, what in the world is this for? Well, this is for the purpose of dealing with shapes that circumscribe a circle. Okay, and that word circumscribes, it comes up on your Canvas problems, and what that means is that all of the sides of this shape, in this case it's a triangle, all of the sides of that triangle ABC are tangent to the circle. Okay, you can see side AB, this line segment runs up and it just touches the very edge of that circle at point E. BC just touches the edge of the circle at F, and AC just touches the circle at point D in the middle right there. Okay, now what this does for us is it lets us answer this question: what is the perimeter of this triangle? And we know how to find the perimeter of a triangle. You add up all of the side lengths. So as long as we can find these missing parts of the side lengths, it'll be easy enough to find the perimeter of this triangle. So let's look at our theorem. Our theorem says that AE and AD, since they're both tangent to this circle and they both start at point A, they must be congruent to each other. All right, so if AE is 6, AD must also be 6. Same thing for BE. BE right over here and BF are both tangent to the circle. They both start at point B, so they're congruent. And as such, BF must also be 4. And it's the same thing for CF and CD. CF and CD must be congruent, and so CD has to also be 7. So to answer our question, don't lose sight of your question. Find the perimeter of this triangle. All you got to do is add up all these side lengths. 6 plus 4 plus 4 plus 7 plus 7 plus 6. That's all we're doing here. And when you add all of that up, it gives us our final answer, 34. All right, 34. That's what we're working with here. That's how it's going to go. Okay? Not the most complicated thing we've ever done in this class, I guarantee it. But if you're having trouble, please, please, please let me know. That's all we're going to have for these notes today. Y'all have a good one.